Hello everyone. Today we'll be discussing on mechanical properties of material. Why we need mechanical properties of the material? What it will help us? By knowing this one, you can select the material properly. Material selection judgment will be good by knowing this one. So let's begin with mechanical properties are the physical properties of the material which describes its behavior under the action of load on it. So for every material, it will have its unique property which is not familiar with other materials. So example cast iron or iron, it can be rusted, but compare with aluminum, it won't rust. It will have a good uh, electric conductivity. These all things. So that's where every material will have its own specific and unique physical properties within. Types of materials mostly categorized as metals and non-metals. So under non-metals, ferrous and non-ferrous. Ferrous are the metals which contains iron. Non-ferrous are the metals which does not contain iron. Example copper, zinc, aluminium, magnesium, etc. The very first mechanical property which we are discussing here is strength. Strength is a measurement of how much a load a material can withstand before it failure without plastic deformation. Here we are having three classifications in it. One is compressive, tensile, and shear. You can by seeing the pictures you can know how it will act. Uh, and by considering the deformation of before fracture, there are three types of strength which we need to consider, and these are the parameters which we will be helpful to understand the material specs given for any material or material alloys. Means which one I need to consider, whether yield strength and or ultimate strength. So yield strength is a maximum maximum strength, and ultimate strength is a final point. So after that, it will start it break even. So this one, this stress strain diagrams will give this graph for or any material how it will travels with respect to the load application. The strength can be calculated by using force and area formula. Below are the machinery which will be useful for testing tensile, compressive, and shear testing. Fatigue strength. Fatigue means amount of cycles a material can withstand under fluctuating stress or cyclic loading upon reaching failure. For this one, best example is like when we hit with an hammer to something, as we apply continuously, with some 50 or 25 cycles, then the material will break, correct? So that's mean the cyclic loading. So this one also a mechanical property a material should have. This can be replicated in this SN curve. The fatigue strength can be tested in the rotating bending test machine. Brittleness. Brittleness is the property which material breaks suddenly under the stress without exhibiting any elastic deformation or change in dimension. Means suddenly it will break. Example, you can see some glass, something, correct? And all brittle materials are shown here. This brittleness will be tested with this Sharpie V knots testing. Stiffness. We should be very keen of understanding strength, stiffness, and toughness. Okay, don't be confused with these three mechanical properties. Okay, stiffness. Stiffness, a material ability to resist significant elastic deformation while loading. The less deformation a material exhibits during loading, that is stiffer. Stiffener is extended to which an object resists deformation in response to applied force. The more flexible an object is, less stiff it is. If it's always longitudinal axis, the material is flexible. This is the machine for testing stiffness. Hardness. Hardness is the property which is defined by a material ability to resist various forms of deformation, indentation, and penetration, which also refers to its resistance to scratching, scraping, drilling, chipping, wear and tear. Means on surface side, if you want to make strengthen, so we'll make this hardness. So these are Brinell hardness tests which will conduct how much hardness a material has. Toughness. Toughness is defined by a material capacity to withstand elastic and plastic deformation without failure. Typically measured by the amount of energy material can be absorbed before fracturing. Resilience. The ability to absorb energy while being elastically deformed and releasing that energy after unloading. This is the point where we can consider like under elastic deformation. But here thing is absorbing the energy. Like springs, we can springs are the materials where we can make we can see this resilience and energy storage with load and unloading application. Ductility, yes, probably we know everybody about the material and its mechanical property, but we won't be aware that this property is ductile. Like ductile is a measure of material's ability to undergo significant plastic deformation before rupture. So if you want to make wires or some rods or something in reduction of the diameter or length, something cross-sectional area. Then we'll pick the materials which are having ductile mechanical properties. Example, we can consider like copper, gold, aluminum, and pictures how it will use malleability and ductility both will be same. uh, Ductility will be useful for drawing wires, but malleability will be used for drawing sheets. This will be the difference. Creep. This is also a very good mechanical property. Like creep, a slow and gradual deformation of a material under certain applied load, measured by influence of time and temperature. Like this is a property where um, the load and uh, applied and applied and left it some time and with some temperature. Then after some days of time and temperature, this due to this property, the material will fail. This property also means whenever we have some application where continuous means load applied, and due to some abnormal circumstances like due to time or temperature, if it might fail, in that circumstances we need to pick a material where the material mechanical property for the creep it should be good enough while selecting. In creep we are having primary creep, secondary and tertiary creep. Starts at rapid rate and slows with time. Secondary creep has a relatively uniform rate. Tertiary creep has an accelerated creep rate and terminates when the material breaks or ruptures. It is associated with necking and formation of grain voids. Machinability. This is also very an important property for any material. Means how much easily a material can be machined. That's the machinability. Um, Due to this only, if it is having hard enough for machinable, and most of the some materials will be useful for tool purpose as well, as it is having a um, good strength for the machinability. So this is a machinability index for different materials. The machinability index will be different. For SS 25, for low carbon steel 55, for copper 70, for brass 180, aluminum alloy 300 to 1500, magnesium alloy 500 to 2000. So like this, it will vary, depends upon its mechanical property. And machinability ratings for different carbon steel, aluminum steel. Damping. Damping refers to dissipate the amount of energy used to create, vibrate, oscillate, or stress. A material with a good damping property such as cast iron is capable of absorbing high amount of vibrations. Okay, a large damping capacity is desired for materials then structures where unwanted vibrations are induced due to operations such as machine tools, base, or crankshaft. Elasticity. Material that rebounds back to their original dimension after deformation or being removed from its load. Every material has a certain elastic limit before becoming deformation permanently, otherwise known as plastic deformation. So from the red color line is a utmost point of a material. After that, it will be plastic deformation. Before that, it will be elastic region. Plasticity, a type of permanent deformation that occurs under stress before before resulting in failure. Homogeneity, these are the material and mechanical properties like homogeneity and aneotropy. Homogeneity, any material that has same properties throughout its entire geometry, that is homogeneity. Homogeneous material cannot be mechanically separated or identified individually. Certain type of homogeneous materials include plastics, metals, glass, paper, resin, coatings. Isotropy, oftenly confused with homogeneity and isotropic materials, exhibit same properties in any direction or orientation, whereas homogeneous materials have same properties regardless of direction. Anentropy, a material that exhibits different properties based on its direction or orientation. For example, in control graphics, thermal expansion. This is a very good mechanical property which you need to consider while designing something in combustion chamber or some heat or high temperature zones. Okay, so a change in shape, volume, or area caused by change in temperature. So these are the different thermal stresses as shown over here. Um, choose a material which thermal coefficient will be good enough. Like the coefficient of thermal expansion refers to amount of materials shape size will change during exposure to change in temperature. So due to which it will affect. Thank you. Hope this mechanical properties will be helpful for understanding your mechanical material selection. Hope it gives you some idea um, which will be helpful in while designing something in for your robust and uh, good design. Thank you.